Hello. Here in this video we're going to check through our answers for the group work. Starting with 18 where it said to copy and complete the table for this exponential function of g of x is equal to 3 to the x. Alright, now you can see here the table, here's the answers, and we got this from taking each x value, taking that x value, and plugging it in for the exponent. So this is 3 to the 0 power gives us 1. 3 to the first power gives us 3. 3 to the second power, which is 3 times 3, gives us 9. 3 to the third power equals 3 times 3 times 3, which gives us 27. So make sure that you're using these x values in that exponent spot with that 3. Now, so to use the table to make a graph, I gave us the suggested axes of how to make our graph. That way we knew how to scale it, because scaling exponential graphs at first is a little different because the numbers grow so quickly. So here's what that graph is going to look like. Now this is just taking those coordinate points and plotting it on there, right? They start off a little small, right? Because 1 was at 3, 2 was at 9, so you can see it's almost there at 10, and then after that it starts to grow pretty quickly. Right? We had the 3 up here at the 27, and the 4 is up here by that 81. Right? Now here it says to identify the constant factor for this exponential function. Now what that's asking us is that's just the what we have as that common ratio. So that's when we're here multiplying by 3 each time. And we can see that as these numbers are increasing, we are multiplying by 3. Alright, so now it gives us an equation about Isaac, and Isaac evaluates the function modeling Tony's grandparents' house value, and it gives us the equation right here. Well, here's our starting value of 10,000, and it's multiplying by 2 for a certain exponent. Alright, and he's saying that this exponent here is 2.5, and the variable t represents the number of decades since 1960. And it's asking us here, what is h of 2.5? And this is function notation right here. So all it's really asking us to do there is to take that 2.5, plug it in for that t. So we're going to have a 2.5 up there in the exponent portion of our equation, And when we type that in, we'll get this answer here. We ran it at 2 decimal spots since we're talking about money. We have some cents there. Alright, so for 22 here, it's saying for which year is Isaac estimating the house's value? Now this is 1985, because if it started at 1960 and it's counting for decades, which is 10 years, 2 would be 20, and then another 0.5 would be an additional 5, so that's adding 25 on to 60, which gives us that 85, so 1985. Alright, so here it gives us a table of values, or it tells us the year as it's increasing by decades. Here's our number of decades increasing, and the house's value. So it's giving us some new information here. So we skipped 23. We didn't grab a graph of it here. So explain how we know that the value of Maddie's house is growing exponentially. We know this because if we were to look back at the table, we can see that it has a common ratio. Each time we are multiplying to get our next value. And you could always take a term, right? So we could take this term, divide it by the previous. You could do that with any of them. You could take this term, divide it by its previous, and we would get the common ratio of 1.5. We're multiplying by 1.5 each time. Alright, so then it's asking what was the approximate value of Maddie's house in 1995. So that's asking us to plug in a number for that exponent. So since we started in 1960, if I wanted 95, I'm going to need 3, because that gets us to 1990, plus an additional 0.5. So if we plug in 3.5 for our exponent in that equation, we will get this value here. Alright, so then it gave us a new set of information. We skipped 26 though. We went right on to 27. And says what was the values of Eduardo's house in 1970? That would us be plugging in a 1, right? Because that's 1 decade past the 1960 to get us that value there of that. Oh no, we started in 1970 this time. Right, so if we started in 1970 and it wanted us the value, we'd be plugging in a 0 for the t, which is why you can see that we had 20,000. Here's that 20,000 showing up in that equation. And the reason that this 1.2 to the t power didn't show up is because if I raise it to the 0 power, all of this portion just turns into a 1. And 1 times 20,000 gives us a 20,000. And then it says approximately how much was the house worth in 2000. That would us be plugging in that necessary value in for our exponent. So since it's 2000, we started in 1970, we plug in a 3 for our exponent right here into that t, and then that would tell us our value.